Redgate!
Thank you very much, Ben. And yeah, thank you very much to everyone else who's chosen to attend this presentation today. And also a quick shout out to Catherine, who's also in the chat and just came off video. She's been a fantastic mentor throughout the process, helping give me feedback on the slides and helping me put the session together. So if you are considering doing some speaking, starting to go through this path, I would definitely recommend the New Stars of Data route. Yeah, it's been a fantastic experience, and the level of support is second to none. So let's get on. Today, we're looking at data warehousing the right way with Azure Synapse Analytics. So first of all, a little bit about me. So my name is Reiss McSporran. I'm a senior BI developer at Purple Frog Systems. Purple Frog is a BI consultancy based in the West Midlands in the UK. And we basically do anything to do with data, from data wrangling all the way through to presentation, Power BI, the whole thing. From my side, working at the business for just over 3 years now, been earning Microsoft certifications the full way through, and you can see there my latest one is my Azure Data Engineer. One thing I will point out here is the Purple Frog Systems blog. I do blogging over there and do talk about Synapse Analytics and a few of the pieces that we're going through today. So go take a look on there, take a look at the posts, and you can reach out to me on any of these areas here. So today, what are we looking at? Data warehousing the right way with Azure Synapse Analytics. What does that mean? Ultimately, Synapse Analytics and data warehousing specifically we're going to be talking around Synapse SQL Pool. And it seems very simple to just move your data warehouse from an on-prem data warehouse, put it in the cloud, and everything's better and faster and great. But there's a couple of pieces that you really need to think about when you're doing that. So distributing data and workload management are two of the most difficult parts to get right, but they're the two that will give you the most improvement for your performance. Get those right, and you'll be off to a great start. So we're going to be looking at setup first. We're just going to go through a little bit of how the environment is set up and have a look through. We're then going to go on to data distribution, take a little look at scaling, then on to workload management, and then we're going to go through our summary and some key takeaways for you at the end. Setup. Creating and configuring your Synapse workspace. So this is the first thing that you need to do. You log into your Azure portal, you type in Synapse in your add programs, and you get this window here. So you choose your subscription, you choose your resource group. So I'm using RM Demo, Reiss McSporran Demo. We get a managed resource group as well, which will be some additional resources that the Synapse workspace needs to program and process. It will create a separate resource group. So I've called my one ancillary, at which point it's just going to put the additional resources in there. My workspace name, so RM Demo Workspace, the region I want it to go into, and then a key piece here is the data lake storage. We need to have an account name and a file system name. You can use existing ones, but here I've just gone for the same, RM Demo Storage Account and RM Demo Storage. That is for the files that are going to be created within your Synapse environment. All of the data for those initially will be saved into your data lake storage. So when you start creating SQL text, SQL query files and different bits that we'll look at in a moment, that's where they're going to get saved. After going through that, on the next page, you then go to security. This is going to be a SQL creation, so it asks for your SQL administrator credentials. We're going to create one here, RM Demo Admin, give it a password, and then a little bit here about allowing pipelines. So that is whether we want to be able to move data around, and encryption down the bottom here. All the data is encrypted by default, but it asks whether you want to do double encryption using your own managed key. So I've said no on that. We click next, we go to networking. You can set up virtual networks and all of those. set up tags, the usual part of Azure resources, review and create. You click create, and then you get deployment in progress. And that will take about 10 minutes, I'm going to go with, but it can take a little bit more, it can take a little bit less, so we're not doing it live. But once that is completed, then what do we get? We get our RM demo storage account and our demo workspace. As you can see here, we go onto our workspace, we click on Open Synapse Studio, and let's go take a look. We click onto that Synapse Studio. As we can see here, it's just Open Synapse Studio here in the middle, the RM demo workspace I've created, and this is the page that we get to. This is our home page. There's a few bits on here about quick starts, so we can just bring some data in, have a look at how to get insights from the data, how to start building Power BI, but the key bits that we're going to look at are these areas over on the left, just to go through in some more detail. So that's the home page. The data. This is where we can access either our workspace. So this is like using SQL Server Management Studio. When you're using your Object Explorer on the left-hand side, you can see your database. You expand it out, you can then see your tables, your views, all of those. So this is for databases that are within your Synapse workspace. And the linked area here is any additional resources that you've connected to. So you may have connected to some other external databases, some other data sources, and in this case, it gives you by default your data lake storage account that you created in the previous step. Moving on to the develop, we then have access to SQL scripts. That is enabling us to literally run live SQL scripts in our workspace here instead of moving over to something like Management Studio. Notebooks, so that's creating some Python notebooks, Spark, those different things, and we can use those to do whatever you want with those notebooks, so machine learning or whatever deep processing you want to do. Data flows, so those are for wrangling data, so that is going to be for actual data transformation. Apache Spark job definitions, so that is for setting up Spark jobs to actually run, and this is where you configure those. And then it's got some options for browsing the gallery, so browsing some ones that have already been created, some templates, or importing some data that you've created in a separate one. Integrate, this is Synapse pipelines. So you can create a pipeline to essentially move data around, import data, export data. So maybe you're going to import some data into your data warehouse from your Azure Blob storage. This is the kind of area where you'd come and do it. And it's also got a simple copy data tool, as it says there, to author a one-time, just copy the data from A to B. But there are, as it says there, over 90 different data sources that you can access in there. So it is a very broad amount of information you can get to. Monitor, we go down here and we can see SQL pools, Apache Spark pools, requests, and this is where we can see what's going on in your Synapse environment, what's been run, how it's run, any errors, and also what's scheduled to run next. But the key piece we're going to be looking at today is this manage area, and specifically SQL pools. This is where you actually configure and set up all the different settings for your environment, so we can see access control, different credentials, connecting to your Git environment, and all those pieces going through. But we're going to stick here at the SQL pool at the top. And we can see here that there is a serverless and also a dedicated SQL pool. The serverless SQL pool, that allows you to query data in place without importing it into a specialized store. So that is going to be doing something like running a SQL query over data that's already at rest in your data lake. So using the develop piece over here, run a SQL query, connect to your data lake and start querying data live in your files without having to import it into a database. But the second part, the dedicated part, the actual data warehousing, which is where we're looking at, is for high performance analytics over transformed and imported data. So in order to get to there, we're going to have to import that data in. To create that, it is as easy as clicking on New, choosing our performance level, giving it a name, choose whether we want to restore from an existing backup, and then review and create. I'm not going to do that right now because if we do that, we get deploying and it says this can take 5 to 8 minutes. It's a very particular figure and it usually does deploy within that time. So moving on, we've now got our SQL pool created and now we want to start putting data in it. Now, the first thing we need to look at is data distribution. So what is it? First of all, we need to look at how Synapse works and how the SQL pool specifically moves data around. So this little screenshot here gives you an idea of what your SQL pool looks like and how the data is accessed and processed. So at the top here, we have a control node. Before I carry on, we've got DMS listed throughout here, and DMS is the data movement service. So at every stage, there is a data movement service that migrates and moves data around these. But at the top here, we have our control node, and this is where our query gets executed. So our application or user connection connects to the control node and runs the query. That then sends the query through the massively parallel processing engine, MPP, and that decides on where it's going to send it. And when we say where it's going to send it, it's going to send it through one of these 60 compute nodes. So obviously there's only 4 showing here, but there are always 60. And those 60 then go to your data storage layer, which is your SQL pool and this idea here of the data that is distributed. So if we've got these 60 nodes, how do we put our data in the right place to use them all? And what we're talking about there is, because the main difference between your standard SQL data warehouse and your SQL pool data warehouse is this idea of compute nodes, we want to move our data to the right locations so that it can all get processed as fast as possible. If we have 60 compute nodes that we can be using, we want to use all of them to run our query as best as possible. We want our massively parallel processing engine to take our query, identify that it can run it on all 60 nodes, and run it on all 60 nodes. In theory, running then 60 times faster than the same query running on a single processor looking at a single piece of storage. It's not quite that simple, but that's the idea. So where do we actually put our data? When we're talking about putting our data into a location, we are still putting it into that one SQL pool, into that one database, and we're only looking at the storage layer. This is not something that you have to consider when you're doing an on-premise database, but it is something you have to consider when we're looking at our Synapse SQL pool. And what we're talking about there is literally, you've got your table on the top, you're going to query it, it's going to do the exact same thing, but where does the data actually sit? No longer on disk, but in your pool. And so we've got 3 different options. We've got replicated. So as this piece here says, all table rows are copied to each compute node. So we would have our table, and say our table has 1,000,000 rows, it would copy that same 1,000,000 rows onto every single one of those 60 compute nodes. And we say, okay, that seems great. That means that our query can just run straight at those compute nodes. It doesn't matter which one it hit, it's going to have the data that's going to be able to run as fast as possible. That's fantastic, except for data storage. You are then storing your data 60 times. So 100 meg of data is now 60 gig of data. 60 gig of data is now 3.6 terabytes of data. So if you've got a lot of data, if you try to do replicated, your storage cost is going to go through the roof. But it is always going to be the fastest type of access. The next one that we come on to is the round robin. distributed. Now, round robin distributed is the same idea as replicated, except for rather than putting the same data onto every node, it just puts the same data on each node in turn. So rather than sending that one line of code and copying it to every single one, it sends that first line to compute node A. And then it sends the second line to compute node B, the third line compute node C, all the way through to 60, and then row 61 goes to compute node A. In theory, that's the way it goes through, and it just continues firing the data all the way through. That's very fast because it only has to write straight away. It doesn't have to do any processing to identify where the row needs to go, and it just fires it all in. So that is good for bringing data in fast, but it's quite quick and dirty. If you actually then try to query that data, do any grouping on that data, you're going to end up with what's called data shuffling, which is this node over here, and this node over here, and this node over here, all have the same data that we want to query. And so before it can do that, it needs to grab that row and put it here, and grab that row and put it here, and then do its processing. So there will always be a data shuffling, and that is very expensive. So how do we get around that? Hash distributed. So hash distributed is, again, the same idea of one row per compute node, but with this hashing function. And the hashing function is basically an idea of you identify what data, how you want to group your data together, and how that data is grouped together goes to each specific node. So in that same instance where we were talking about this replicated and a round robin, if we said that, okay, we want to be reporting on this data in this way, therefore everything to do with a specific customer always goes to that one node. Then if we are doing any query around customers, grouping customers together, we fire our query out, and we know that because we're grouping by customer, each node is handling that one customer, reducing that data shuffling and basically eliminating that expensive operation. And that is very fast. But you need to think about that around what is the group by statement for your data? How are you actually going to query that data? What is the group by function that you're going to be trying to do? And you need to be thinking about how you're going to report on the data before you start loading your data. And that's something that really hasn't needed to be done before you come to this SQL pool. Get this right now so that you can increase your performance from the start. And the way that you always want to be looking at this, just quickly on those, round robin distributed, as we said, it's the same idea as this one here, but without the hashing function. So it just throws one row as it goes through. And our order of consideration is this row left to right. So first of all, can we distribute the data by the same thing? And when you're looking at your data, you always want to try and group as many of your different tables by the same distribution, so that when you're grouping different tables together, they're all of that data is going to be on the same node. So if you're doing sales by customer, you also want the customer's address, the customer's record, all of those to be on that same compute node. So you try and distribute all of them by possible. If that's not possible to do any hash distributed, then let's take a look at round robin. Is that the right thing to do? Or can we do replicated? Most likely, you're going to end up with hash distributed for your fact data and for your large dimensional data, and replicated for your small dimensions. Something like in this same sales scenario, maybe you're going to have the replicated one as your store, because there might only be a small number of rows, so it's okay to have those on every node. Maybe you're going to have your date dimension, your time dimension, all of those are going to be replicated. But what's the syntax? How do we actually set that up? So using the good old AdventureWorks fact internet sales, we've just got a standard create table query here, and that would run in your standard SQL environment. To get this to run in our Synapse SQL pool, we need to add this with clause down the bottom here. So with this clustered column store index, And the key piece, distribution, we want to hash by product key. So this is for our distributed data that we were talking about before with that hash. So we're saying here that this is going to be, we're going to be doing most of our reporting by product, and therefore we are going to distribute our internet sales by product. That's great. However, if we are going to be doing our reporting by customer or by order number or something along those lines, it's then going to have to start shuffling that data around. So maybe the actual way that we want to be running this is by customer key, because that's our primary reporting method. We need to look at what our group by function is, not what our where clause is. So the other thing that you would say logically, you're looking at these, another key on here, order date key. Let's choose that one because all of our reporting by date, let's make everything by date. No, don't do it. The problem with that is you're always going to be grouping by date, at which point if you say, let's bring back a complex query over all of the sales for a particular day or for the sales for the last week, all of that day's worth of sales is then going to that one compute node, not spreading out across all of them. So now we're making one out of our 60 nodes doing all of the processing for that single day, meaning the only time you would ever hit all 60 nodes with that is if you're doing more than 60 days worth of processing. And there is always going to be a better way to do it. So you need to be thinking about what kind of distribution. You need it to have many unique values because you want this to sit across most of the nodes fairly equally. The column can have duplicate values, and that's going to be expected because then all rows with that same value are going to go to the same distribution. Since there are 60 distributions, some distributions are going to have more than one, more than 10, more than 100, depending on what the cardinality of the data is. And then some of them are going to have potentially 0 values. Maybe you do only have 59 unique values in your data set. Therefore, one of the nodes is never going to be used. That's okay, depending on how your data goes through. You don't want that column to have nulls, ideally, because if we said in this same idea, maybe our fact internet sales, maybe only 20% of our internet sales have a customer key. The rest of them are null. We just don't take the customer, they've signed in as a guess. If we've got null in that data, that null counts as a value. So all of the nulls would go to a compute node, and then the rest would go to the others. Meaning we then have a data skew of 80% of our data on one node, and then 20% across the other 59. That's not good in terms of processing. So we need to take a look at that. And as we covered, not a date column. So let's make sure we avoid those. This same piece here, this distribution equals hash product key. To do the other two that we talked about, to do round robin, we just change that to round robin. To do replicated, we change it to replicate, not replicated. So in a nutshell, that is our setup of our data and how to do data distribution. Questions? Do we have any questions at this point?
We do have a question from actually a little earlier from Gopi, and again, I hope I'm pronouncing your name right. If they provision both Synapse SQL and Azure SQL DB on the same server, can they access Azure SQL DB from Synapse Studio?
Yes, you can. Yeah, you can basically connect to that same environment and run queries, run queries against them. The only thing that you can't do in those is to do basically cross-server queries. So you'd need to bring that data into kind of one location. So either exporting the data and importing it into your data warehouse, or doing an external table, creating an external table in your SQL pool. So if you take a look at external tables in Synapse SQL, you can see that you can essentially set up within your data warehouse a connection to any other system, and it will treat it as if it's just a table in your existing environment. So that's the way to get around those cross database queries and cross server queries is to set it up as a external table. Those external tables can be used for other SQL databases, but also things like your data lake files and things.
Cool. And another question from Jamie. Can you distribute on multiple columns? And if you can, should you, shouldn't you?
So no is the answer. It always goes by the one key that it's going to be distributing by. And you basically wouldn't want to, even if you could, because if you do have an instance where you actually want what we'd be terming that as like a business key, and you want all of those pieces to go together, the way to do that is to, in your data set, join them together as kind of a distributable column. So say I'm going to group by, can't think of a good scenario, but say we were going to do it in that instance as the order number and the customer. We wanted to group by both of those together. If you put that as a concatenated column in your data set, so you just select both of those columns together in your source data, you could then distribute by that column, which would do essentially the same thing. But it's always dependent on the type of reporting that you're going to want to do.
Okay.
One of the main things that you need to look at around there is this is not the only way that you can do reporting. You can still obviously have all of your indexes that you would usually have on your data to speed up query processing and to do all of those. This is just where the data sits at rest to stop data shuffling.
Cool. And there is one follow-up, and you tell me when to stop asking your questions because you're master of time. But I think it works very well with the previous question. Shall we use different distribution for different tables in the same database?
So the way that you choose, there is no right answer for distributing any of your data. It always comes down to what your data is. And that's what that slide when we were going through and showing the order of precedence is, does it have a valid reason to distribute it by a specific column? If you're going to distribute it by that specific column, can we use the same one that we've used for a lot of the rest of the data? Because that's going to stop us doing that data shuffle. If we can't, maybe we'd end up with 2 or 3 different types. Maybe we have, in that same instance, we have our customer distribution, and everything that has customer goes onto those specific nodes. Maybe we also have promotions. Maybe we have a lot of detail about promotions, millions of rows of data. So we're going to have a distribution by promotion key as well. And then we end up with 2 different types of distribution by hash, and that's totally fine. And then we decide, like we said before, that we also want date in there and time in there. Those are then going to be replicated. So you can have different distribution types, and you can definitely have different hashing algorithms to hashing keys to use for your distributed tables. It's really going to be take a look at your data, what's most sensible. Take a look at how many rows you've got. Do you actually want it to be replicated? Can you afford that data storage? Those. Usually we'd identify the central one, the round robin, as the staging data for just when you're doing a mass import, and then you move primarily to the replicated and the hash distribution for your end model.
Okay.
This is probably the last question I can take at this moment.
Okay, cool. We'll save the remaining question for the end.
Well, I'll take this final one from Yopi now. So in the same example, you showed the fact table. We have multiple surrogate keys in the fact table. On what basis I need to select the particular surrogate key for hash distribution, or do I need to go with round robin? So again, that is dependent on your reporting scenario. So if you were going to write your report as just a full SQL query, so you're going to report on all of these different metrics and you're going to group it by what at the bottom? What is that key reporting term that you're going to group by at the bottom? That is what you want to hash by. So in that example, I showed that it depends on, maybe we want to always group by product. Sales reporting by product is the most important part. We don't care whether someone bought one or many most of the time. We don't really care necessarily immediately how many different products they bought. We care how many products sales were done per product. Then we would distribute it by product. If we were mostly caring about customers, so the sales that each customer made, we were doing customer metrics, then we're going to distribute it by customer. You can, if you have a massive data set and you have both of those are equally valid scenarios, you can put the same data into the database twice with different names distributed by those different keys, if that's the scenario that you need. But I would recommend trying to put it in with the most used scenario and then try and get around putting the data in twice with indexing. See whether you can get the performance that you need out of that, or whether you need to try looking at saving that data twice. Okay, I think we'll move on from there. Thank you very much for those questions. If there are any more on the same subject, then stick them into the chat, and then if we have time, we'll cover those later on. So now we're going to move on to scaling. How high can we go? We've got two little parts here. We've got our performance level, DW100. I'm going to come back to that in a moment. And we've got an estimated cost per hour of £1.24. Great. Let's scale it up. We then go to 3000. That's 30 times higher than 100. And it's basically 30 times the cost. Higher is higher is higher. That is basically what it is. You put the performance level higher, the cost is higher, and the performance higher. Mostly. Let's look a little bit deeper into that specific. First of all, we need to look at what is a DWU. So that DW100 that we were talking about and the DW3000, Microsoft says CPU, memory, and I/O. These three resources are bundled into units of compute scale called data warehouse units, or DWUs. In the old world, you would look at your server and you would go, we're getting throttled by CPU, we need to add a new CPU, we need to dedicate more cores to that server, maybe we need more RAM, our I/O, we're suffering on our I/O, maybe we can go to faster SSDs, maybe we can do that kind of thing. That's not really possible in Synapse. The option that you have here is just to give it more DWUs, and it should give you more CPU, memory, and I/O together. It's a little bit difficult to identify what that means underneath, but more is better in terms of performance. That's about all you can kind of glean from it. They say that increasing DWUs linearly changes the performance of your system. So if you have 100 and you go to 200, it should be twice as fast. And it also increases the maximum number of concurrent queries and concurrency slots. So at the basic level, which we'll go on to in a moment, you can have 4 concurrent queries running, and then higher up you can have 32, 64 different concurrent queries running on your data. But we'll go into that in a bit more detail in a moment. DWUs is quite a complex subject, so for more information on those, look up Synapse DWUs on the Microsoft Docs website, and you'll get a ton of data and a ton of information. But let's go take a look. Let's do some more demos. So, as I said before, we've got this demo SQL pool. All we do here is we click on this scale button, and as we had in that that previous image I was showing on the slide, we have this performance level, and we have DW100. Drag that up, DW3000. 30 times the cost, 30 times the performance. Fantastic. The slider can go higher, but as soon as you try to make it higher, it says it's limited in this region. The cost starts to get quite expensive, and if you move across again, you then end up with different quotas you'll have to discuss with Microsoft, and that gets into a lot more stuff. So we're going to look at scaling from the minimum DW100 to the maximum DW3000 for the region that I've put this data in, which is UK South. Let's do this, start the changes. So I've scaled that. I haven't actually clicked the button, but the reason why I haven't clicked the button is it takes about 5 minutes or so to scale. The other thing to know when you're scaling this up is it will cancel all of the queries that are running at the time. It needs to make sure that there are no queries running. So this is not something that you can just do in the middle of the day on your production database. You're just going to go, okay, let's scale it from 100 to 500, 500 to 1,000, and then run some queries and scale it back down again. Because every time you do that scaling, it's going to take it offline for around 5 minutes, sometimes more, sometimes less, and no queries can run at that time. So it's really something that you need to do in a maintenance window, maybe 6 a.m. before queries start coming in. Maybe you spin it up earlier, run your overnight ELT, and then scale it back down again. Those kind of things, you need to look at those. So we've scaled it up, and we've then run an expensive query. And we've taken a look at the metrics in our monitor tab that we were looking at earlier, and we're going to see how much of our resource is being used. But before we do that, small RC. So you're going to see small RC in a moment. And what that is a workload group, and that is the default workload group. We've not touched on workload groups yet. That's coming next, but I need to mention it now because even though we've not touched on workload groups, you are always using a workload group, whether you configure them or not. And default is small RC. We're going to go into it now as to what the benefits of that are and what the downsides of that are, but know that it's the default and it is there so that you can start using the system without causing yourself problems. But as soon as you start doing it anymore, you're going to encounter problems. And these are the problems that you'll see. So on our DW100, we've run our large query. We should be using all of our resource. We've come into here, had a look at our max resource percentage, and we're only using 25%. Why? We don't know at this moment. So let's scale it up to 3,000. If we're only using 25% with small RC, whatever that means, let's scale to 3,000, 30 times more, 25% of that is better than 25% of 100. Let's just do that. I've scaled that up, I've run that same query, but now we're getting 3% of our maximum resource usage with that same query. Maybe my query is just bad, maybe I've written it wrong. I haven't. The point of this is that this is where our workload management comes in. So to give you a rough guidance, DW100, if we've got 100 DWUs, whatever those mean, we're using around 25 units for our query there. If we're scaling up to DW3000, we're using about 90 units of our DW3000. We're getting 3.6 times the performance about for around a 30 times cost increase. That doesn't seem great. Let's have a look at why. Quickly into here. We want to look at that in a little bit more detail. So when we click on this scale button, it's then saying consider using the workload management scale experience instead. If we click onto that, that then gives us this screen, which gives us a bit more information. We can see here this DW100 has a supported concurrency of 4, meaning it can run 4 queries at once. And if we're going to run 4 queries at once, the maximum it's going to be able to use is 25%. That makes sense. If we then scale up to 3,000, it's going to run 64 queries at once. The allowable resources per request has gone for 1.5%. That would make sense in terms of those. We saw 3%, so there is a little bit of flexibility in there. But now, all of a sudden, just by scaling, we can see we're in workload management. We're looking around it in more detail. So let's move on. Going back into that workload management, we can see we can't see any workload groups in here because by default, it's looking for our user-defined workload groups, the ones that we've actually created. We've not created any yet, so let's take a look at the system-defined ones. And if we look at these system-defined ones in here, let's just select a couple here so we can get an idea. We've got small RC, and there we go. That's the one that we were talking about before. And we've got this extra large RC. The minimum resources per request, if we move over to the right-hand side to these effective values, the minimum resources per request, 25%, but also the maximum resources per request, 25%. When we were on DW100 before, we can see that's where that's coming from. If we were to say instead, try using this extra large RC, we can see on there that we're going to be getting 70%. Okay. The good part about this is if we decide to start scaling, these numbers down the bottom will also reflect what the new values are going to be. So it's all a little bit grayscale, but we can see here that on the new one, the brackets here, that maximum resources per request, that key one there, goes to 3 for the small RC and 70 stays for the large RC. So what does that mean? That means if we go to that DW3000 and we run that same query with those different workload groups, small RC, extra large RC, 70% of resource versus 3% of resource. That's 23.3 times more resource usage for no extra cost. But how do we get more? How do we get more than 70%? Custom workload management. So let's take a look at that. So if we discard these changes and we can go up here to our new workload group, this is where we're going to create these user-defined ones, which was blank earlier. It gives you a few suggestions of, is this for an ELT? Do you want a load of resources but very few queries? Or is it for your dashboarding purposes? Do you want quite low resources but a high concurrency? You can have lots of users hitting it at once and you want to give them each a little bit of performance. The key takeaway from this is there is no one workload group that is going to work for all of your scenarios. You need to set up these different workload groups. And what we're going to go on to now is the classifiers and how we actually assign those different ones. So I've said that I've used this small RC and then gone to the extra large RC, but how do we actually go between them? The small RC is the default. Everything will always use small RC until you configure something different. So to configure the different one, I've come into extra large RC and we've got over here this classifiers option. Click onto that number and then you click add classifier and you get this window here. So let's look into that in a little bit more detail. As you saw, we clicked onto that classifiers option, got that option and we clicked add classifier. And then we got this box came up. It's fairly simple to go through, but there is a lot to go through. So we're going to go through at some pace, but hopefully we can all keep up. The first piece here, name your classifier. A unique name, totally fine. Give it a dashboards board or ELT machine learning or whatever's going to make sense. Then we get onto the member. Who is actually going to be using this workload classifier? So when a query hits the database, what user or role has that come from? Meaning which workload classifier, which workload group are we going to use? To identify what the user is for your testing purposes, run this select username. And the reason behind that is this user that I've granted access to and while I've set it all up, this would actually come in as DBO as the username rather than my actual username. So running that query against your SQL pool will identify what the user is. You'll be able to track through the permissions and you'll be able to apply the right member or role based upon your SQL permissions. Then we've got our request importance. That's fairly simple in terms of if the same query hits the database at the same time, which one of them has precedence. If there are some waiting queries and there's some that are high and some that are low, the high will go to the top of the list. If you've got multiple high, then you'll have first in, first out as the usual label through. Then we have the complicated part, which is these bottom three parts. Label. So label is available for queries that run so that you can see them both in your query store and also for these classifiers. Now, what is that workload management? What is that option? That is a label you can apply to any query. I'm going to go over how that works in a moment, but that is any query. You can apply this option on the end, and when it submits to the system, it will be identified as that rather than just a query ID. That is one of the good ways to do it. The next one is time. So for example, we want all of the users under DBO to have this massive resource percentage between the hours of midnight and 6 a.m. and then move back down. So we might want to have some specific times. Or maybe you want your dashboarding resources, so to go really high concurrency at 8 a.m., 9 a.m., something like that. And the last one is session context. So session context is a variable that is session bound rather than batch bound. So what do I mean by that? Usually, if you set a variable and then run a query and then hit go, if you try to use that variable again, it's not going to work. You'd have to redeclare it. With a session context variable, for the entire session, that variable is going to be valid. So the specific variable it's going to look for is this WLM underscore context. This is the query for how you set it. Using store procedure, set session context with the key of WLM context and the value of whatever we want to call it. So this big query and big query here, just a name I've come up with, all you'd have to put is big query in there or big query in here, and then make sure that all of your queries have that on the end, or all of your sessions start with this. But how does all of that run through? There is a precedence order, and those go in a weighting. And the weighting is just an additive as it flows through. So we have, first of all, username. That's the highest one. Then with 64 weighting, then role, which is 32, then label, which is 16, and then a nice, interesting, useful order here. We go 8 down the bottom and then back up to the middle for 4. What do I mean by those weightings? I mean that if we have a query that comes through and 64 and 16, so we've got a user in here that has come through with this option label big query. That has a weighting of 80. If we then get one come through with a username and a context and the specific time, that's only going to get 76, 64, 8, 4. Therefore, it's going to pick the first one. So you need to be aware of that order of precedence. If it does match, then it's just going to use the first one that it comes to. So there's quite a lot to go through there. But again, if you go and do Googling, go have a look at the Microsoft Docs, you can look at that in a lot more detail. But what's the syntax? How do we actually set them up? A standard select star from fact internet sales, go. We've run that. That is going to look at our user and our role, and also the time that the query is running. That's what details that one's going to use. If it can find one, it's going to use it. The next one, select star from fact internet sales with this option, label big query. That's now labeled this query with big query. And now we could see that in our query store, but also in the back end. And the classifier is going to identify that we've got big query. So it's going to use the user role and the time that it's run and the label. And it's going to find the right workload group for that. And the final one is this set the session context and then go, and then select star from fact internet sales and then go, and then select star from fact internet sales where the sales amount is greater than 42. That is going to use user role time and session context for both of these queries until we open a new window, start a new session. So when do we use each of them? This one up here, that one is going to be used for the majority of the queries that hit your database. That's the standard. Anytime someone runs a query on like a Power BI, something like that, it's going to come through in that order. So that's going to be your key. The next one with the labeling, that's going to be good if you are running some complex queries that are going to be manual. You get your developers to add that option label into it, and by using that option label, they can identify how much resource they want to use. Maybe you've got ML query that's going to really have massively high performance but low concurrency, or you've got to think about the scenario around there. And then these session context ones are going to be more for your ELT. You're going to open a session, you're going to run a load of different queries, but you don't want to have to put this option label into every single one. Setting it at the top, all of the queries will run over the same. So that's going to be the way to go through. Now, what do we need to think about when we're doing workload management? Unfortunately, other people exist. You need to think about your system usage, your volume of users versus the performance of your queries. You can't just assign every user 100% of resources because you'll just cause waits all over the place. How many users are going to be querying at once? How complex are the queries they're going to be running? You need to identify these different pieces. You need to create custom workload groups and assign those classifiers. The system-defined groups are a great starting point to get away from that small RC, to start leveraging the power of the entire estate, but they're not great for flexibility. You need to start looking at the custom ones. And you need to assign those AD groups to different workload groups with different priorities. How important is it that the report loads quickly for just an end user versus the operations manager versus the board members? I'll let you decide who's going to be most important. And then you need to assign specific times for specific workloads. So your overnight ELT, your large machine learning query, things like that. 100% of resources, maybe it's okay at 2 a.m. Maybe you do just want to hammer the server 100% at 3000, DW 3000, just to get your machine learning query done. Fantastic. But you don't want to hog 100% of the resources all of the time. So you need to look at those carefully. But the key point is test it, monitor it, amend it. Monitor it, amend it, monitor it, amend it. It's a never-ending cycle. It's a constant development cycle you should be going through. Listen to your users, find out what's going wrong, find out what's going well. Monitor the usage stats during heavy loads on the server and during low loads on the server. Maybe you can assign more resources per user during low usage periods. Maybe you need to assign less resources per user during high usage periods. You need to look at those, and then you need to twist those pieces and amend them as you go through. There's not ever just a right answer. So, questions. A lot to go through there. Let's have a look. So I see Catherine's posted in the chat the link to the DWU's document. Thank you, Catherine. So how is scaling and concurrency, etc., related? Yes, so let's take a look in here. So scaling and concurrency. If we have a look, the concurrency that we have by default on DW100 is a concurrency of 4. That is basically specified by Microsoft as the limit of what they would be acceptable in terms of performance. I see Alex has linked the document in there already, but as you scale the system, we can see that that concurrency is 4, and if we scale up, we get more concurrency. And all that is it's basically just a hard limit of how many queries you can actually run during that. When you're creating your custom resources, if we do go on and create one here, if we start to assign different resource percentages, so if I set this as 50, you can then see that our concurrency range changes because we've said that we need a minimum resources per request of 50. So the maximum concurrent queries we could have is 2. So there is a hard line of our resource percentages versus our concurrency. But this is a very complex topic, so you do need to go and do more reading on it. And as I said, test it, monitor it, identify what's going on. Do we have any other questions? I'll hold on a moment here while we wait.
So nothing on the chat and nobody raised their hand. So if you just want to go ahead and then we'll take it at the end if something pops up.
Perfect. Okay, so our summary and key takeaways, what you need to remember. What have we gone through today? We've gone through data distribution. That is how you manage your data in terms of where it gets put. That's all about the storage layer. Not saying that this table goes to that node, this table goes to that node. It's saying your table exists in your environment, but where does the data actually sit underneath? We've then gone on to scaling. We've gone up and down, we followed the slider, and we saw the concurrency changing. More is more, higher is higher. That's about all you can get from that. But workload management, you are always using workload management, even when it's not configured. This is the big one, and it identifies who gets access to what resource at what time and what priority. That's really the key. So data distribution, as I alluded to in the questions earlier, the correct answer always depends on your data. You need to just try it. You need to try it. You need to query your data. You need to look at where your performance is. Have a look at the query execution plan. Are you getting a lot of data shuffling? If you're getting a lot of data shuffling, then you need to look at your data distribution. You need to identify where your pain points are and take a look at it in that way. There is never a one correct answer for everyone. Scaling. Scaling up will give you more performance, 100%, all the time, unless your query is really badly tuned. But it's always going to be limited without workload management. It's very complex to get right, but it is fundamental to high performance. You really need to take a look at your workload management. And with the two of data distribution and workload management, getting those two right will allow you to save a lot of money in terms of scaling. If you were scaling up to DW3000 to get that kind of performance without doing workload management and having your data distribution in the wrong place, maybe you could go to 1500 if you do them right. Maybe you could go to 1000, maybe you go to 500. The cost benefits are crazy considering how relatively simple it is to just get started and make those tiny changes. There is a lot of performance available in the system, but not all of it is straight out the box. You need to look into these and try them. And if you do, you'll then be well on the way to doing data warehousing the right way with Azure Synapse Analytics. I'm Reiss McSporran. Thank you very much for listening.
Yeah!